So today we'll just be solving some hard SAT problems. And yeah. So in this first problem, 34z to the power of 18 plus bz to the power of 9 minus 30. And we know that qz to the power of 9 plus r is a factor, and q and r are both positive integers. What is the greatest possible integer value? B. Okay. So first let's rewrite it as 34x squared and bx, just to make it easier to see. And now we know that, then let's just write q z to the power of 9 plus r to just as qx plus r, just to make it easier. Then we know it has to be another factor, so let's just label it as mx plus n to make it easy. So now we know that q and m have to equal 34, and q times n plus r times m has to equal b, and then r times n equals negative 30. Okay, so now we're trying to find integer values of b. So let's say that r equals 30 and n equals negative 1, because that's the possible values we could get. Now let's just say q equals 34 and m equals 1. So now if you go back to b and we have all our stated variables, we can see that q times n, that's negative 1, but then m times r, that's 1020. So you can try the numbers if you want, but this is going to be our greatest possible integer value of b. So yeah, just give me a second to write it. Yeah, so that one wasn't too bad. You just have to think about what numbers will get you the largest possible value. So in this one, the height of a triangle is increased by 50% and its base is decreased by x%. The area of the triangle is increased by 20%. What is the value of x? So we know that the area of a triangle is 1/2 base times height. So let's just write that down. So it's increased by 50%, so that means times 1.5 for the height. So let's just rewrite that in our equation. And now we know that the base is decreased by x%. So x over 100 plus 1, that's how we would write it as a percent, times the base, then times 1/2, and this will equal the new area. So we also know that the new area is equal to 20% more than the area of the old triangle. So what we're going to do here is we're going to set 1.5 times our decrease in x% equal to 1.2. So once we do this, we can just start to solve for x. just simplified the 1.2 over 1.5, brought everything down, and then we'll subtract, and then times by 100. So once we do this, we can see that x equals -20, and we know it decreased by x%, so that means it decreased by 20%. So yeah, this one wasn't too bad either. You just have to understand the percentages and how to rewrite them even when you don't know what exactly they are. Like when we were saying the base decreased by x%. Numbers a and b are each greater than 0, and 4 times the square root of a is equal to 9 times the cube root of b. If a equals 2/3, for what value of x is a to the power of x equal to b? So we know that a and b are both positive, and then let's just write out what they gave us. So 4 times a square root, I'm just writing it as to the power of 1/2, equal to 9 times b to the cube root, or to the power of 1/3. And we also know that a to the power of x is equal to b, but they want to know what x is. So let's just plug in the 2/3. So 4 times 2/3 to the power of 1/2 is equal to 9 times b over b to the power 1/3. So let's bring the 9 to the other side. Now if you notice that the numbers 4/9 and 2/3 actually do have something in common. 4/9 is just 2/3 squared. So we can rewrite this equation as 2/3 squared times 2/3 to the power of 1/2 equals b to the power of 1/3. So now since our bases are the same on the left side, we can add up the exponents. So this will get us 2/3 to the power of 5/2 equals b to the power of 1/3. And now since we want to isolate b, we can do b to the power of 3, but then we'll also have to do it on the other side. So this will get us 2/3 to the power of 15/2. And now what they wanted was a to the power of x equals b, find x. So we actually already solved for that here because a does equal 2/3, so then x would just equal 15/2. So for the exponential function f, the value of f of 1 is k, where k is a constant, which of the following equivalent forms of the function f shows the value of k as a coefficient or base. So what they're trying to say is which one shows k in the original function when it says coefficient or base. So we know that when x is equal to 1, the function is equal to k. So that's what we're trying to find. So the best way to go about this one is to just plug in values. So for a, let's just plug in 1. So we get 50 times 1.6 to the power of 2. And that gets us 128. So since it's not 128 isn't in the coefficient or base, we can cross out a. So now let's try b. 80 times 1.6 to the power of 1, just 80 times 1.6. It's also equal to 128, but that is not anywhere in our function, so let's try c. So 128 times 1.6 to the power of 0, that's also equal to 128, but 128 is in our function, so c is the right answer. But let's just check d. So d, we get 127.5, which is nowhere in our coefficient. That's one of the only few that you'll have to actually plug in numbers and check. So a regular hexagonal prism has a volume of 350 and a height of 14. What is the perimeter of the hexagonal bases in inches? Okay, so let's just draw out our picture first because that will make it easier. So that's the height and that's just the base. So we know that volume is equal to base times height, and the height is 14. The volume is 350. This means that the base will be 25. So now the thing about hexagons is that they can actually be drawn into 6 equilateral triangles. So the area of each equilateral triangle in this case would be 25 over 6. Using this, we can now find the area of each triangle, which we'll do in a moment. And since we want the perimeter, we can use the area of each triangle to find the side length of each triangle, or the side length of the hexagonal prism. And then this will allow us to find the perimeter. So if you don't know the formula for an equilateral triangle's area, we'll go over it in a second, but this is how you can solve it if you can't remember the formula. So we know that it's a 30, 60, 90 triangle, and then so S, and then the 30 side is S over 2, then the 60 side is S root 3 over 2. So now we know that the area of the triangle is S plus 2 over S plus 2 times S root 3 over 2 times 1/2 equals the area of a triangle. So now if we just add like terms, we get 20, or let's just plug in the area first, 25 over 6. Then if you just add up like terms, you get S squared root 3 over 4 is equal to the area, or in this case 25 over 6. So let's just take the 4 over. And I can see that this is going to be a weird number, so I'm just going to bring everything over first and then see what to do. So I brought the root 3 over, but since I can't have a root on the denominator, because my calculator won't allow that, I'll have to rationalize. So you get 100 root 3 over 18 after rationalizing, and that's equal to S squared. So then we're just going to square root both sides. So now I have what S is equal to, and since I need the perimeter, I'm just going to do 6 times S. I just put it to the power 1/2 to make it easier for me to see. Then P is equal to 6S. So then if you just plug that into the calculator, you will get P equals 18.6 inches. Thank you for watching. Please let me know if you have any other problems. Feel free to leave them in comments, or if you have any questions about the problems we did today. Thank you.